So let's talk a little bit about safety before we begin. Checking our fuses. This is basically, if we shut this off, I have it disconnected. It's unplugged, so I have control of the plug. I don't have to wear this arc flash stuff just quite yet. If we look at this, we'll see that as this swings open, if we have an arc flash, which can happen, because if you look inside of this disconnect, you will see that there are small blades. And those blades, if they don't engage correctly, here, you'll watch the snap action. I think you can see the blades come in and out. If one of those sticks and you apply a load to this, this can actually become overheat and melt and start an arc flash. So let's talk about the proper way to turn off a disconnect, and then we're going to use the cross-check method to check our fuses, and we're also going to ohm out a fuse. So with your arc flash stuff on, we're going to zoom back out. The old way was, it's kind of an old electrician trick to kind of, you try to work with one hand, but they used to teach you to stand like this, and when you fired on a disconnect, stand away from it. Okay, the old way was this way, but if this blows up and you're wearing your arc flash and you're standing over here, all the sparks are going to come up in your face. So the new way, this is the proper way, is that when you get ready to energize this, you stand to the side and you turn it on. That way, if there is an arc flash when you power it up, it's going to blow out. You've got your gloves on and long sleeves, and you're not going to get hit. So I'm going to energize this, and we're going to do a cross check. And let me zoom in just a little bit. And we're going to cross-check our fuses looking for a blown fuse. Somebody bring a meter with a magnet. Yeah, great, thank you. I got it. Hopefully that will stay in there, and we'll put it 600 volts. All right, that's pretty good. So I'm going to energize this circuit, and I have my disconnect off. We're going to open the door. We're going to engage the circuit and use the cross-check method to check our voltage. So starting on the source side of L1 to the fuse side of L2, I'm going to check my voltage, and I'm reading 208. I'm going to shift to the source side of L2 and check to the bottom. We're checking L3 fuse now. And so I'm going to check here, and I should be reading 208. Now I'm going to switch. So I'm going to go to the source side of L3 and check to the bottom side of L1. and I should be reading 208. That tells me all these fuses are good. We have a three-phase system here. So if there was an issue, we would not be reading, we would be reading 120 volts on this system. Let's look at it when I insert a bad fuse into this system. We're going to pull this off. We're going to remove this, and I'm going to insert a bad fuse. So when you remove these fuses, it's a good idea to use a fuse puller. Sometimes you'll see people pry them out with screwdrivers or use channel locks, but the appropriate tool to use is a fuse puller. So now let's do our cross check. Again, we're going to check from L1 source to L2. Should be reading 220 volts. I'm going to check from L2 source to the fuse side of L3, and I should be reading nothing because I don't have the power on. Here we go. Here we go. So now we're reading 220 volts for 208 because it's three-phase, and we're going to check from here to here, and I am reading no, we're not reading anything right through here. So I'll check up here. I'm reading 208, but if I go down here, there's no continuity for path to flow, so I'm not reading anything. So I know that fuse is bad, but I can double check that by pulling it out. Firmly grasping it, I can turn my meter over to ohms. You have to apply a firm grasp to this to make sure you get through there. And we'll see that first I want to check my meter to make sure my meter is working. And my meter is working. I want to grasp the fuse and check it. And I'll see that that fuse is open. Now, sometimes you can get tricked because if you have a control transformer hooked up to this, by the way, if I was checking this on a standard industrial system of 480, I'd be reading 480 across the different fuses, but to ground I'd be reading, or across fuse, be reading 277 on one phase. I have a 220 volt three-phase system here, so we're not reading that, or 208 volt. So let's see if we can actually check this to ground. And I have a control transformer in the circuit. I'm going to come over here and put this back on the voltage. And I'm going to find a ground up here. So I have a ground wire. I'm going to check the ground. And I'm going to check across the top of each one. Here, I'm reading 120 volts to ground. Here I'm reading 120 volts to ground. Remember, this fuse is bad, so what am I reading here? I'm still reading 120 volts to ground, but that fuse I know is bad because I just pulled it out, tested it, and put it back in. Here's the problem. If you don't watch it, what you will do is you will actually read through the control transformer. So here we have the control transformer hooked up, and the current is actually coming off L2 going all the way back through the coil and coming back to the bottom side of L3. So when I checked it to ground, I'm actually reading the voltage coming off L2 with the disconnect on. So you have to be careful of that backfeeding through the circuit. If I wanted to do this, I could disconnect, pulling the fuse on the doesn't do any good. You've got to disconnect it. So we've disconnected it. And if we come over here and check from ground, I will see that I now read no voltage. Before, on this side, I was reading 220 volts. So remember, when we turn these off, we should not be facing these. We should be standing out of the way. There's another video where we apply a lockout, but remember, don't stand in front of these when you turn them on. If they do have a load on them, there could be an arc flash. Right now we have a system with nothing on it. There's not going to be an arc flash. And if we stand in front of these can become projectiles. So the proper way is to stand backwards, stand facing it, and turn the disconnect on to make sure the sparks don't blow back under your helmet.